Okay, you are welcome back to Introductory Mathematical Analysis A, and we are still in chapter 8. Okay, just in chapter 8, and this time around we are going to go into section 8.7. Okay, chapter 8.7. In chapter 8.7, we're going to be talking about Bayes formula. Bayes formula. Okay, before this, let me quickly mention about that Bayes formula. This Bayes formula is named after an English statistician, and the name is called Thomas Bayes. Okay, Thomas Bayes discovered this formula in 1763. Okay, this formula describes Bayes formula or Bayes theorem or Bayes formula. It describes the probability of an event based on prior knowledge of the condition, that might be relevant to the event. Okay, that is the Bayes formula. It describes the probability of an event based on prior knowledge of the conditions that might be relevant to that event. Okay, this Bayes formula or Bayes theorem is very applicable in many fields, in economics, data science, in engineering, in finance, in so many fields. Okay, all right, let's go. And then now we learn about, before I explain this formula for you, we learn about the conditional probability before. Recall, let me quickly recall for you. Recall our conditional probability if E given F. Okay, what is that? Then it is probability of F intersect this over probability of F. Okay, you know that before. All right, now in this Bayes formula, of course, this also is the same thing as probability of F given E multiplied by probability of F given E multiplied by probability of E. Multiplied by the probability of E. You remember, you can recall in one of the conditions, we also have that probability of E intersect F is equal to probability of E given F multiplied by probability of F is equal to probability of F given E multiplied by probability of E. You remember that? We mentioned that before. Okay, all right. So now in this Bayes formula, we are looking for is the conditional probability of Fi. So this I is an index that can go from 1 to up to this n, Okay, so the conditional probability of Fi, given that E has occurred, can be expressed as this. Okay, don't forget I told you this I is from 1 up to n. So if n is in 3 parts, let's assume let n equals to 3. Then we're going to have f1, f2, and then f3. Okay, we're going to have that. All right. So, but if f is in 2 parts, if n is in 2 parts, then we're going to have f1 and then f2. All right. So now let's rewrite this formula using n in 2 parts. Let me just use n in 2 parts. So I'm going to have the probability of f1 given e equals probability of e given f1 multiplied by probability of f1 all over, you just write this the same. You write that the same, probability of e given f1 multiplied by probability of f1 plus, then you write the other side of f1. Don't forget we said n equals to 2. That means f1 f2. Then we have the other part of it, which probability of e given f2 multiplied by probability of f2. All right, so that is for f1. Don't forget we are still assuming that n equals to 2. So we can get the other side of f1 with this formula again. So probability of this given e is equal to probability of e given f2. Don't forget we are dealing with f2 now. Multiplied by probability of f2 all over probability of e given f2 multiplied by probability of f2 plus probability of e given f2. Okay, I wrote f2 first, so I can now multiply by f1 now. All right, so you see, because n equals to 2, we have 2 parts to f. So this is for when we are finding f1. We have the probability of e given f1 multiplied by probability of f1 and this. If you look at the denominator, this denominator is the same with this one. So either you write this first, or you write this first, is the same. Okay, because of the addition that is there, so it's the same. All right, so you don't need to start with what is up first. You can just write the sum of all the parts. You see, the sum of all the parts. Okay, that is it when f is in 2 parts. But if f is in 3 parts, so let n equals to 3. So that means we are going to be having f1, f2, f3. So if I want to say probability of f1 given e, will now become what? It becomes probability of e given f1 multiplied by probability of f1 all over probability of e given f1 multiplied by probability of f1, then plus probability of e given f2 multiplied by f2, then plus, don't forget it's in 3 parts, probability of e given f3 multiplied by f3. Okay, that is when it is in 3 parts. The same thing goes for f2 given e. All what that will change is just only the denominator, the numerator, only the numerator that will change all over. The whole thing that is there, should be here. The whole thing here should be here. Okay, that is for that one. Then if I want to find f3 given e now, so I'm going to have probability of e given f3 multiplied by probability of f3 all over the whole thing, also the whole thing. So the denominator is the same thing for all of them. the denominator is the same thing for all of them. Okay, that is Bayes' formula. All right, so again, you need to know which one is given, which one you are looking for. That is very important. That is very important. Okay, all right, so let's go. Now let's take this example. Microchips are purchased from ABC, okay, from supplier ABC, or from company ABC, or from firm ABC, and are randomly picked for assembly each camcorder, for assembling each camcorder, okay? 20% of the microchips come from A. 20% comes from A. 35% come from B and the rest from C. Okay, so if you have 20, 35, then the remaining one will be this plus this minus 100. I think it's 45%. Yeah. So we have 45% from C, 35 from B, 20 from A. Okay, C. All right, so let's go. I want to be able to pick out what we need. Okay, the probability that A is defective is this. Okay, the probability that A is defective is this. Okay, probability that the microchips from A is defective is given like as this, and the corresponding probability for B and for C is given. So A defective has a probability of 0.03, B defective has 0.02, and C defective has 0.01. Okay, a camcorder is selected at random from a day production and its microchip is found to be defective. A camcorder is selected at random from a day production and its microchip is found to be defective. So they have given us defective. Given defective. Take note of that. And its microchip is found to be defective. So they have given us defective. So we have defect. So we have probability of something given defective. So if we let D to be defective, okay, and we say S1 is supplier from A, supplier from company A, okay, supplier from company A. If I say S2 is supplier from company B, supplier from B, and say S3 is supplier from D, from C rather, supplier from C. Okay. All right, now let's read the question. This is given already, so let's now see what they want us to find. So now, find the probability that it was supplied from A. Don't forget again, a camcorder is selected at random from a day's production and its microchip is found to be defective. So we already given defective. Now the first one is I want to find that it is from A, and we said A is S1. That means supplier from A is S1. So that means we are looking for, please make sure you take note, we are looking for S1 giving D. Okay, that means we are looking for supplier from A giving D. Okay, so, but this supplier is in how many parts? Is in 3 parts. In 3 parts. Okay, we have 3 types of supply. So now we have S1 giving D. What will be the formula? It will now be probability of D giving S1. multiplied by probability of S1 all over the same thing, probability of D given S1 plus probability of S1 plus, multiply, this is multiplication, multiplied by probability of S1 plus probability of D given S2 multiplied by probability of S2 plus probability of D given S3 multiplied by probability of S3. You see? So you see, we are looking for from supplier from A. It is supplier from A. That's why we have probability of S1 given D. Okay, so we need the value of this. Okay, we are going to come to that and put their values so that we can get the probability. But let me quickly write this again. Probability of S2 given D is just the same. It's just the same, only that this now will now be changing to S2 all over the same thing we have here. The same thing we have at the denominator will be here. Okay, that is from S2. Okay, now probability that is from C. From C, this is probability that is from B. Is from B. Is from B. Then probability that is from C will now become probability of D given S3 multiplied by probability of S3 all over the same denominator. Okay, so we are going to put the values now. Let's look at it for the values. Okay, if you look at the question again, then you get that the probability of A, we have it here already. So probability of from A, which is S1, is given as 20%, which is 0.2. Okay, the probability that is from B, which is S2, is 0.35. Probability that is from C, which is S3, is 0.45. Okay, now probability that defective from A, that means we are looking for this probability of defective from A, So probability of defective from S1, don't forget S1 is called supplier from A. So is this one 0.03. Okay, probability of defective from B, from supplier B, is 0.02, and probability of defective from supplier C is 0.01. Okay, so we just need to put all these values into the formula and we get our probabilities. We just put all these values into this formula and we get our probability. Okay, that is it. So if you put that there, as I mentioned before, then you get this, and then your probability of S1 given D will be 12 over 35. Okay, so if you go for the second one and we put the value of the probability also, you're going to see the denominator is the same. Okay, the value of the denominator, the sum in the denominator, is the same for all of them. And then for probability of S3 given D, we also be given as this, and then we also have the same denominator. All right, please make sure you understand. All right, thank you.